Hello everybody, welcome to the Henstitute. In this problem, this is probably our most convoluted of the more kinematic problems because there's a couple little pieces to it. And one of the things that always throws people off is the fact that it talks about the race car is starting from rest and it has an acceleration of 6 meters per second squared, and for 4 seconds it takes to enter the main speedway. So they're not sure what to do with that, along with the constant velocity of this other car. And then as you kind of keep reading it says it wants no time, and people are like, but it's 4 seconds. So it just kind of throws people off. The biggest thing I think with this one is try to get kind of an idea of the problem. So let's assume that the pit is down here and our car starts out here. So this is going to be a top view of my car. So this is how I draw top views of cars. So the wheels, and there's the top of the roof of the car, and we're good. So the idea is the car starts out here, it's 0. So it has an initial velocity of 0, and it's going to basically accelerate and get onto the track. And this is going to take 4 seconds to do, and it has an acceleration of 6 meters per second squared, or 6 meters per second per second. That's important. Then it is now on the racetrack. So it has just entered the raceway, as they put it. So here is the car right here. At that moment in time, another car, I'm just going to make it green, happens to be side by side with it, right as it gets on the raceway. But this car is already traveling along. It's already taking off. It's moving this 70 meters per second. So 70 meters per second. And it's a constant velocity. So whenever they say it's a constant velocity, you can say that its average velocity is 70 meters per second. That's probably the easiest way to think of it. What we want to know is if the entering car maintains its acceleration, this green car is going to pass him. So if you've ever turned onto a road and all of a sudden another car goes flying by you, then you know you're going so much slower and they've got a faster speed, so they're going to go flying by. But if you were to take off after him, eventually you could catch him. So at this moment in time, we know the two cars are side by side. What's going to happen is sometime later, they're going to be side by side again. So what we want is we have to realize this displacement is going to be the same for both. Because they were side by side, then we can use that to our advantage. Also, they were side by side at initial time equal to 0. At some time later, which we don't know, they're going to be side by side again. That's what we're trying to actually find. We're trying to find TF. Now I'm not going to put an F on it. I'm just going to say we're finding T. We're trying to find the elapsed time. But here's the cool part, is that it is also the same for both. In other words, if you were to start your stopwatch when you pulled onto West Boulevard just as a car goes flying by you at 45 miles per hour, and you started your stopwatch, but then you accelerated and they kept at constant speed, and eventually you caught back up with them and stopped your stopwatch, you have both traveled for the same amount of time, and you've both traveled the same displacement. That is actually very important. So we're going to use that to our advantage. What we have to deal with is the fact that when you enter here, you have a velocity. So what is that velocity? Well, we're going to use this part of the motion, the initial going from the pit up to the raceway, to help us out. So you started at VI of 0. You're accelerating at 6 meters per second for 4 seconds. So what I'm going to do is I'm going to find the final velocity during this part. So it's going to be that VF equals VI plus AT. And so it's going to be 0 plus 6 multiplied by 4. And VF would be 24 meters per second. Now, that's the final velocity of you leaving the pit and going onto the raceway. But now we're moving on to this pink section over here where we just care about being on the runway. Or raceway, sorry. So it's a VF here, but for the motion right here, it's going to become the initial velocity. That's the weird part. Is it was the final of pit to raceway, but now on raceway, it's the initial velocity during this little pink section where the x's are the same. So here's what I'm going to kind of point out. So I'm going to switch the blue just slightly. So for this one, what I'm going to do is the x is the same. So I'm going to come up with an equation for x here, because we know that you have an initial velocity of 24 meters per second. You're going to continue at this 6 meters per second squared, and you're after time, but we know the x's are the same. And you're like, wait a second, but I don't know what x is. Well, just kind of bear with me. So the equation I'm going to write for this car is this one, that the x for this car is going to be the initial velocity times time plus 1/2 the acceleration multiplied by time squared. Now the reason I'm going to use that one is I want an equation that solves for x where it has the initial velocity, I have it right there, the acceleration, I have it right there, and it has the missing time. Now if I knew x, if I knew how far it was from this pink section to that pink section, I'd be good. I don't. So I'm just kind of bear with me. I'm going to hold off for a second. Now I'm going to come up to this car. I'm going to come up to the green car here to find its displacement. Since it doesn't actually change, it would just be its average velocity multiplied by time. Well, what did I say? This x and this x are the same. The x's are the same for both. So here's what makes this problem a little bit harder. We're going to set these two equations equal to each other. So since they're both x, I can set them equal to each other. And so here's what we come up with. We come up with that the average velocity for my green car times the time should equal, and now I'll switch over to the blue, the initial velocity of the blue car multiplied by time plus 1/2 a t squared. And you go, okay, how do I solve that for time? Well, let's put our numbers in. So I'm going to change colors here so you can kind of see what I'm doing. So my average velocity here is 70, and it's multiplied by t. So I got 70 t's. And then I'm going to switch over here to my initial velocity. This is the 24 multiplied by t, because it was 24 when it entered this raceway, plus 1/2 times my acceleration, which is 6, multiplied by t squared. Now what I have is I have a big algebra problem where I have to solve for t. Now I always get a few people who are like, I can't do that, it's going to be quadratic and I don't want to use the quadratic formula. Well, one, we may run into situations where you have to use the quadratic formula here in physics, but this one actually doesn't. And the reason why I know it doesn't is everything has a t with it. So one of the options is time could be 0, but that doesn't make any sense because that's when they started, but it says entering the catch and catch the other car. At what time are the two cars side by side? Well, one time that they're side by side is right at the beginning, so at time 0. So that one actually works mathematically, but it doesn't work for what we're trying to figure out. We want some later time. That's what we're after. But if you can solve this lovely algebra problem, you've got your time. Hope that helps. Like I said, this is a fun little kinematic problem. It just has some extra little pieces that makes it a little bit more complicated. Hope you enjoyed.